Okay. When you are estimating the median from a histogram, if you know how many data points there are, you can use the formula n plus 1 divided by 2 to find your middle observation. In this case, for question number 9, we're told that there are 17 quiz scores. That means we know that n is 17. That's our sample size. So we take 17 plus 1 divided by 2. That's 18 divided by 2, which is 9. That's not the median. That just tells us where the median is. So we are looking for the 9th observation. So where is that? The way that you look at a histogram, you start from the left-hand side and you think about how many are in each bin. You need to figure out where the 9th observation is. What bin is it located in? In this first bin here, there's 1. That's the first observation. The second observation is here. That's the first and the second observation. Then the third observation is located here. And then in the next column, it is 2 high. So the 4th and the 5th observations are here. And then the next column is 3 high. So that's 6th, 7th, and 8th. Which means that the 9th observation is here. And these histograms, that they're going by 4s. So this would be 8, this would be 12, this would be 16. So in the histogram bin, from 16 to 18 is where the median is. So it's any number between 16 and 18. Now, I haven't told you whether this is a left-hand histogram or a right-hand histogram, meaning most of our histograms are left-hand, which the lower value is included. So it could be 16, 17, or less than 18, depending on, are the quiz scores, are they whole numbers? We don't know that much. But we don't know the exact value for the median. We can only tell you a range because the histogram doesn't give you exact values because it's giving you ranges. It's going by 2. Now, how do we determine which measure of center to use? I talked about it last module. I just talked about it in the previous video. But if your distribution is skewed, you use the median. If the distribution is not, you use the mean. So if there's outliers present, you want to use the middle because the middle is resistant. The median is resistant to outliers. Guarantee you this is going to be a question you would see on a test. Which measure of center should you use and why? Well, what does my picture look like? Does my distribution look skewed or is it symmetric? That's going to tell you. Those are things that you want to get in your vocabulary. Skewed, I use the median. Symmetric, I use the mean. Think about this. In NAPA, we have these home prices. Let's imagine that the average home price right now is $500,000. So we've got a distribution. This is not realistic, but in our distribution, let's say that every single home price in Napa was $500,000, the uniform distribution at this point. Now, with that $500,000, that would mean that the average price would be $500,000 and the median price would be $500,000. But if, let's say, Mark Zuckerberg decides he wants to come in and build a $50 million compound, that's going to take the average and raise it. It's going to skew the distribution to the right. The middle is going to stay 500,000, but the average is not, which is why we use the median instead of the mean in a skewed distribution. Okay. We want to revisit the serial data from module 7, and we want to make a histogram for all quantitative variables. And they want to have 3 rows and 4 columns. So we're going to go back to Statcrunch to create a histogram, but what we're going to do is we're going to put all of them in one picture together. Here we are in Statcrunch again. Let's pretend we don't know how to load data. So what we're going to do is we're going to go to data and load, and we're going to do a shared data set. And we're searching for serial. And remember, we want the one that is Statcrunch featured. And now we want to create histograms for all 11 quantitative variables. We go to Graph, Histogram, and I want to select all. You can do Control A or Command A if you wanted to. You could hit calories and hold the Shift key and go all the way down to the bottom. That works as well, but you want to make sure you have all of them. You need to go down to the bottom of this window though, and you want to put 3 rows and 4 columns. Then we click Compute. You could add the mean and the median just to kind of see. That would tell you whether your distributions are symmetric or skewed. Here are all of our histograms. We want to then list which one would be better using the median, which one would be better using the mean. So we're going to go back to our guided notes, and I'm going to draw on top of our histograms to kind of give a picture as to which one would be better. Okay, for calories, we've got one hump. There is a little bit of a difference between this left-hand side and this right-hand side, but it's not enough for us to say that this is not symmetric. I would call this distribution symmetric, and so I would say I would use the mean here. For the next graph, protein, that's not symmetric, and I would say we are skewed to the right. Remember, more of the data is to the left, and I would want to use the median. Same thing with our fat. We're skewed to the right because more of the data is to the left, and we would want to use our median. For our sodium, it's not symmetric, and it is skewed to the right. It's hard to see because you've got a gap here, but we've got, you might even say that it's bimodal, but in this case, you definitely want to use the median. Fiber, skewed to the right, we would use the median. Carbs, we've got this little peak right here that's a little bit different from the right-hand side, but I think that you can use the mean here. For sugars, the left-hand side doesn't look identical to the right-hand side. You could maybe make an argument for a bimodal distribution here, saying, okay, you've got a group here and then you've got another group here. But that being the case, because you've got a lot of data on the left that's high and then a few on the right, you could probably use the mean or the median here. Potassium, clearly the median because it's skewed to the right. Vitamins, clearly skewed to the right, median. Weight, I would say, is symmetric. We would use the mean. And with cups, I would say that that's symmetric and you could use the mean. Even though there's a little bit of a dip, I don't think that they're far enough apart to be considered that different. A, you would say the medians, which are the proteins, the fat, the sodium, the fiber, the potassium, the vitamins, and then for part B, you would list the means that I had just said. Now, the next question, part C, says, which ones are the mean and the median both equally good? Anytime you use the mean, you can really use the median because they should be equal in a symmetric distribution. So for those that we said the mean on, which was calories, carbs, sugars, weight, and cups, we could also use the median. Okay. Now we're going to look at the histogram that is just potassium. And for this histogram of just potassium, we want to know what would be the average? What do we think the average is going to be? Well, remember that the distances are equal on either side, and it's not going to be right in the middle because this is skewed to the right. So the mean is going to be closer, the median is going to be closer to where the actual grouping of data is, and the mean is going to be a little bit to the right. I would say that the mean is probably right in here. Where would you put that fulcrum to balance? So I would say that it's probably around 100. The range of values for the median. Remember, we can't get a specific value for the median. Where is the middle point? The middle point is probably going to be to the left of that, between 50 and 100. But we know how many, where the observation lies specifically. So we want to use that n+1 divided by 2. There are 75 observations in this distribution. If we added 23 plus 20 plus 19 plus 6 plus 3 plus 2 plus 2, that means that there are 75. So we take 75 plus 1 divided by 2, or 76 divided by 2, which is 38. The 38th observation is going to be our median. In the first, then there's 23. In the next one, there's 20. So 23 plus 20 is 43. So the first through the 43rd observation are in those first two columns, which means that in the second one is where the median is. So the median is going to be between 50 and 100. We want to now calculate what's called summary statistics using Statcrunch, where we're going to calculate what the mean and the median actually are. So going back to Statcrunch, we go to Stat, Summary Stat, by column. We'll always do by column because we enter our data in like this. And we want potassium. And then we click Compute. And now we have our summary statistics that pop up. In the summary statistics, you see the sample size, the mean variance, which we haven't learned about how to calculate yet, the standard error and the standard deviation. Again, we haven't learned how to calculate those yet. The median, which is the middle at 90, the range, and the maximum, the minimum, the Q1 and the Q3, which you will learn about in the next section. So the mean for this data set is 98.6 repeating, and the median is 90. And we said our median was going to be between 50 and 100, and we said our mean was pretty much close to that edge, so we're spot on. Let's go back to our guided notes to finish up. For this potassium variable, which measure of center is best for this variable? That's what we want to know. Well, first of all, what's the shape? Potassium is clearly skewed to the right, and it's unimodal. Well, skewed right, we know that we need to use the median. The median is more accurate than the mean in this case. It's a better representation of the typical value. For calories, considering the shape of the distribution, how do we expect the values of the mean and the median of calories to compare? Well, looking back at calories, that was our first picture here. We said that calories was symmetric, and we said that we would use the mean. When you have a distribution that is symmetric, the mean and the median should be equal. So I imagine that the median and the median are going to be roughly the same. I'm going to go back into Statcrunch, and this time I'm going to select calories instead. And when I compute, I get my summary statistics. The mean was 106.883. Remember, in this class, 3 decimal places. And the median was 110. Pretty close together. Last question, did I get this? A college statistics class conducted a survey of how students spend their money, and they asked 25 students to estimate how much money they typically spend each week on fast food. They determined the mean was $31.52, and the median was $32. Later, they realized that a value entered as 2 should have been 20. They recalculate the mean and the median. Which of the following is true? So they had a low value that they feel like should have been in the middle for the average. They're still both below. 2 and 20 are both below what the average is. Will the mean also increase? And will the median increase? Will the median increase and the mean stay the same? Will the mean stay the same and the median increase? What's going to happen here? Well, our average, we are adding more money. Our average is going to increase. So the mean is going to go up. But our middle number, both those values were below where the mean was and the median was. 20 and 2 are both below 32, which was the median. So it's not going to change. That 32 is still going to be the same value because it just means that one point kind of moved over. It wasn't a new point that was added in. It was just 20 was added. And so the median is going to stay the same. So the mean will increase, but the median will stay the same. Thanks for watching. Head on over to Module 9 to learn about the interquartile range and the 5-number summary.